Assalamu alaikum student. Today we are discussing about the electrolysis and the different cases of electrolysis. In the previous lecture we have discussed the molten cases. How does positive ion metal, they travel towards the cathode, gains electron in the molten form, silvery white appearance, they deposit it at cathode in the molten state. Now today we have to discuss the new concept about the electrolysis if solution is being prepared. Solution are two different types. Number one, concentrated, and number two, dilute. What is the difference of aqueous solution concentrated and aqueous solution of dilute? Today, we have to discuss and learn about the aqueous solutions. That solution which contains water is known as aqueous solution. Solution also be prepared when grease or oil mixes in petrol. This also be a solution because solute dissolve in solvent. But aqueous solution is specific. When a solute, any kind of ionic compound dissolve in water, this type of solution is known as aqueous solution. Like salt solution, sugar solution, alcohol solution, they are solutions. So types of solution about quantity. Number one, concentrated. That solution which contains more amount of solute but less amount of solvent water is known as concentrated solution. Similarly, dilute solution, the solution contains less amount of solute but more amount of solvent. This is called dilute solution. Here we have a list again, reactivity series, which is POSO ka mazil, high QI, the potassium, sodium, calcium, magnesium, aluminum, which are these metals can be electrolyzed by using their molten compounds. But below aluminum, zinc, iron, lead, they can be reduced from their minerals by using carbon, or during the extraction of iron we have discussed. Iron oxide combined with carbon, as a result molten iron can be produced. So iron, lead, copper, these three metals can be reduced by using the carbon, but copper also be reduced by using hydrogen. So copper can be reduced by using carbon as well as hydrogen gas. So hydrogen gas can be used to reduce copper compound into copper metals. Reactivity series decreasing upward to downward, or reactivity decreasing stands for uh, difficulty to release the electron but efficiency of accepting the electron. So potassium can easily be removed their electron, but it cannot accept the electron during electrolysis. So in the previous lecture we have discussed a lot about the metals which are present in the reactivity series above hydrogen, like lead, iron, zinc, aluminum, magnesium. These metals can be electrolyzed, but they never be discharged in presence of hydrogen if solution is dilute or concentrated. Now, first case of a concentrated solution we have to discuss. This is the conclusion. The result at cathode and anode are same if current is passed through concentrated aqueous solution of sulfuric acid, nitric acid, even dilute solution of sulfuric acid, nitric acid, or HCl, HBr, HI. Hydrogen gas should be produced at cathode and oxygen gas at anode with the ratio of 2:1. If concentrated solution of HCl, HBr, HI is there, then hydrogen gas at cathode and chlorine, bromine, iodine gases at anode, but the ratio is 1:1. What does it mean? For your consideration, we have two different cases. Number one, concentrated aqueous solution of HCl or dilute aqueous solution of HCl, even HBr, HI. If concentrated solution, the result in the case of X and the dilute solution in the case of Y is written over here. When HCl dissolve in water, less amount of solvent, more amount of acid. So this solution is known as concentrated aqueous solution. Result remains same. Even HCl, HBr, HI, or any other ionic compound which is soluble in water, which contain these types of metals, sodium, lithium, potassium, rubidium, cesium, results are same. Means When hydrogen dissolved in water, it produces an aqueous concentrated solution. So, beta, we have hydrogen ions in the solution and two different negative ions in the solution. Chloride ions are more in number due to the more quantity of solute in the solution, and OH ion from the water, they dissociate in the less quantity because water amount is less than the solute. Solute is HCl now. When electric current is passed in the solution, what happens? These positive charge containing ions hydrogen, they travel towards the cathode where they accept electron. As a result, hydrogen gas is produced. In the other case, anode is the positive plate. Chloride ions are more in number. That is why they just travel towards the anode where they lose their electron and chlorine gas is produced. The ratio of hydrogen and chlorine is 1:1 because 1 ml of HCl, 1 ml of hydrogen gas is obtained, then the same amount of chlorine is also obtained. If 10 centimeter cube hydrogen is produced, then 10 centimeter cube of chlorine is produced. The ratio remains 1:1. If even it is 100 centimeter cube, so chlorine also 100 centimeter cube. If 1 dm cube hydrogen is liberated, then 1 dm cube of chlorine is liberated. So remaining ratio is same, is to 1:1. What happened in the remaining solution? Hydrogen is evolved from the solution as hydrogen gas, and chlorine can be removed from the solution. So remaining components are hydrogen and hydroxide ions. So beta water remains in neutral condition. So concentrated aqueous solution of any ionic compound along with a polar acid like HCl, HBr, HI, solution remaining solution is neutral, which do not change, which does not change blue litmus to red or red litmus to blue. There is no change on litmus paper. Gases are hydrogen and chlorine gas, they remain. Before discussing the dilute aqueous solution, we should consider the one more case. This is the concentrated aqueous solution of sodium chloride. When sodium chloride is dissolved in water, a solution became concentrated. So we have two different types of ions here, sodium positive, chloride negative from the salt, and H positive, OH negative from the water. We know that in the reactivity series, sodium is above, then the hydrogen. So sodium cannot accept electron because highly reactive metal can easily donate their electron. This is the characteristic property. This is called reactivity series. So hydrogen is below in the reactivity than sodium. So beta, so hydrogen cannot easily remove their electron, but easily accept the electron. So that is why sodium, potassium, lithium, rubidium, cesium, magnesium, calcium, aluminum in the concentrated form, they never be discharged at cathode, but hydrogen easily. Because hydrogen is least reactive, when electric current is passed, so beta least reactive hydrogen can be discharged at cathode. Beta hydrogen gas is obtained in the ratio of 1, and similarly, two chlorine atom, two chloride ion produce chlorine gas when they release their electron. In the case number 1, there is a little change in the remaining solution. Sodium ion are present in the solution, hydrogen does not. Chloride ion can be removed by the electric current in the form of chlorine. Now, we have sodium ions in the solution and hydroxide ion in the solution. So that is why solution is basic due to the presence of sodium hydroxide or potassium hydroxide or calcium hydroxide. So when hydroxide are there, resulting solution is basic in nature, alkaline, which turns red litmus blue. But keep this thing in your mind, the ratio of the gases which are collected at cathode and an anode is remain same, 1:1. Either solution of aqueous concentrated HCl or HBr or HI, solution remains neutral. But if solution contain lithium chloride, sodium chloride, potassium chloride, bromide iodide, if these metals ions are there, these metals ions are there. So these ions never be discharged at cathode, but hydrogen gas should be obtained. If these salts contain negative charge chloride, bromide, or iodide, then these iodide, chloride, bromide ions, they travel towards the anode positive plate because they are more in number against the hydroxide ion, which are less in number. So chlorine gas or bromine gas or iodine is formed in the gaseous state. This is called concentrated aqueous solution of ionic compound and concentrated HCl, HBr, or HI. Now, we have to discuss another case, aqueous dilute solution of HCl, HBr, or HI. When electric current is passed before electric passage of current, HCl should be dissolved in water, less amount of solute HCl in the more amount of water solvent. So now this case, chloride ion becomes less and hydroxide ions are more. At cathode, when electric current is passed, these positive hydrogen ions, they travel towards the cathode, they accept 4 electrons. As a result, 2 moles of hydrogen gas is produced at cathode, means negative plate. But chloride are less in number than hydroxide ion. As a result, chloride cannot be traveled toward the anode, but hydroxide ions are there. When hydroxide ions travel towards the anode positive plate, they lose their electron. As a result, 1 mole of oxygen gas is formed. But the remaining solution is acidic. How? Because hydrogen evolved from the solution, hydroxide discharge at anode from the solution, remaining solution contain H positive ion and Cl negative or Br negative or I negative ion. With a HI, HCl, HBr, they are the acidic in nature. That is why remaining solution is acidic. The result is same if you remember. If dilute solution of HCl, dilute solution of HBr, dilute solution of hydrogen iodide, even dilute solution of sodium chloride is used, result is same. Result is same. Hydrogen gas in the 2 moles and oxygen gas at 1 mole at anode can be discharged. Here is a little change. When concentrated aqueous solution of HCl is electrolyzed, solution was neutral. Gases which are collected at cathode and anode are 1:1 ratio, equal volume of gases. But in the dilute aqueous solution of HCl, HBr, HI, even though if I use NO3 or H2SO4, then the result remains same. But resulting solution is acidic. Resulting solution is acidic. It turns blue litmus red, but the gases which are collected at cathode and anode are the ratio of 2:1. 2 part hydrogen and 1 part of oxygen gas. With the same result in the case A, dilute aqueous solution of LiCl, lithium chloride, lithium bromide, lithium iodide, sodium chloride, sodium bromide, sodium iodide, or potassium chloride, potassium bromide, potassium iodide, means these metals are there in the salt aqueous solution along with the negative ions chloride, bromide, or iodide, one of them. The result at cathode and anode is same. Look like dilute aqueous solution of HCl. So result remains same like dilute aqueous solution of lithium chloride or sodium chloride and all chloride, bromide, iodide, but dilute aqueous solution. In this case, if we have sodium iodide in the form of compound dissolved in water, so when sodium iodide is dissolved in water, what happens? It happened dissociate into sodium ion and iodide ions, while the hydrogen ions from the water and hydroxide ions from the water as well. We know that hydrogen is least reactive than sodium, potassium, calcium, magnesium. So these highly reactive metals cannot be discharged at cathode if solution are aqueous diluted or aqueous concentrated. So beta, only hydrogen gas is produced due to the migration of hydrogen ions towards the cathode. Hydrogen gas is formed. With the same result in the dilute aqueous solution of HCl, HBr, HI, even even hydrogen iodide, HNO3, H2SO4. If these acids are in aqueous dilute form, then the results are same. Results remain same. Two parts of hydrogen gas at cathode and one part of oxygen gas at anode. So we have to learn this thing. There is no change in the result of the product which are for at cathode or anode as well. Now, this is the condition for the electrolysis of different solutions. Now we have to proceed in the next level. Sodium ions are more reactive than hydrogen, so hydrogen gas is produced at cathode, while hydroxide ions are more in number. That is why oxygen gas is produced at anode. Anode is positive plate and cathode is negative plate. Now, more examples for your consideration and for your easiness are here. If concentrated aqueous solution of lithium, sodium, potassium containing bromide, chloride, iodide. So when we dissolve potassium bromide in the water, concentrated solution is produced. So beta hydrogen ions is discharged at cathode in the ratio of 1 because concentrated salts compound produce one part of hydrogen and one part of chlorine, one part of bromine or one part of iodine gas. But in the dilute condition, hydrogen gas and oxygen gases are formed. The ratio of 2 is to 1, 2 part of hydrogen and 1 part of oxygen. I just need to highlight this segment. Similarly, you can check the result, what happened in both the solutions. Now, when potassium bromide means HCl concentrated or any ionic compound concentrated is electrolyzed, resulting solution is basic. Same as above, same as above, when concentrated HCl is dissolved, solution was neutral. When concentrated aqueous solution of ionic compound, the resulting solution is basic, which does red, litmus blue, and the ratio is 1 is to 1. Only one concentrated case of HCl, solution is neutral. Solution is neutral. Now, if dilute aqueous solutions, when dilute aqueous solutions of ionic compound are electrolyzed, solution is neutral, but ratio of gases is 2 is to 1, 2 is to 1. So we have different examples which have been shared for your easiness. Now the last case should be discussed. If the concentrated aqueous solution of acids are there, what happened? Concentrated aqueous solution of sulfuric acid, concentrated aqueous solution of nitric acid are there in the solutions. So beta sulfate and nitrate cannot be discharged at anode at all. So result of aqueous dilute solution of any acid remains same as concentrated H2SO4 or concentrated nitric acid and dilute aqueous solution of sulfuric acid or dilute aqueous solution of HNO3. It means that if concentrated sulfuric or nitric acid is there, so sulfate ion and nitrate ion would not be discharged at, never be discharged at anode. So the remaining hydroxide ion should be traveled toward the anode. As a result, oxygen gas is formed while hydrogen gas is produced at cathode. What is the similarity of the case dilute aqueous solution of H2SO4 and aqueous solution of nitric acid? but the results are same. Hydrogen gas is produced in the ratio of 2 and oxygen gas is produced in the ratio of 1 by the traveling of hydroxide ion and its decomposition in water molecules and oxygen gas. So we can say that only concentrated HCl products are different, but concentrated aqueous solution of sulfuric acid, concentrated aqueous solution of nitric acid, dilute aqueous solution of sulfuric acid, or dilute aqueous solution of nitric acid, with the four cases are there, but results are same. Solution is acidic, which turns red, blue litmus to red, blue litmus to red. This is the same product can be obtained at negative plate cathode, 2 parts of hydrogen and 1 part of oxygen. All solution, 4, concentrated aqueous solution of sulfuric, dilute aqueous solution of sulfuric acid, concentrated or dilute aqueous solution of nitric acid, their results are same without any change. But after the completion of this topic, we have to finish our lecture today. But concentrated aqueous solution of HCl and dilute aqueous solution of HCl, their results are different. In the concentrated HCl, HBr, or HI, their results are same, concentrated. When HCl dissolve in water or HBr dissolve in water or HI dissolve in water, so beta chloride, bromide, iodide are more in number. So they just discharge at positive plate, means anode, chlorine gas, bromine gas, or iodine gas. But the ratio of these gases remains 1:1, and the resulting solution is neutral. Even though acid is dissolved in water, when the current is passed through the concentrated aqueous solution of these acids, not sulfuric, not nitric, so the resulting remaining solution is neutral and the ratio of gases is 1:1. But the dilute aqueous solution of HCl, you can consider with the same result above in the case here. Now we just reduce the size of the document. You can compare these things again. Now here are the cases of little bit 10% further reduce the size. So we are able to compare all these cases now. Little bit more. Yes. Now you can see and check concentrated aqueous solution of sulfuric, dilute aqueous solution of sulfuric, concentrated nitric acid of the aqueous dilute nitric acid, but their results are same as it is like HCl, dilute aqueous, HBr, HI, their results are same. 2:1 ratio, 2:1 ratio because OH ions are more in number, chloride, bromide, iodide are less in number. As a result, resulting solution is remain acidic because H can be evolved from the solution with the OH ion. So H positive and Cl negative are there. So beta, these substances are acidic in nature. So resulting solution also acidic. Now we have to complete our lecture about the aqueous and concentrated, so aqueous, dilute and concentrated solution of ionic compound as well as acids. In the next lecture, inshallah, we will discuss about the copper sulfate other than acids, copper sulfate with the active electrode and the inert electrode. What happened with them? So now we have to finish our class. Okay, inshallah, we will see you again in the next lecture. Allah Hafiz.